So we're missing a few today. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Oh, would you mind putting an L in front of your name, please? So one of the reasons why I use this sign-up sheet is it's something you should get used to whenever you're doing team work. It becomes a part of the record. It shows who's been involved and who's actually there. So for me, remember we talked about that professionalism. I've kind of got 15 points for each of you for a week. Being here is 3 points. Participating is 3 points for 2 days. That's 12 points. And professionalism, being on time and treating each other well, give you the other 3 points. So it totals up to 150 points for the class, which, like I said, is more than the final or any other element of the class. So being here, being on time, and having the opportunity to spend an hour and a half with me is really one of the great benefits of this class. So today, hi, sign in and do me a favor and put an L in front of your name on the list. Okay, so today, one of the things I was interested in is there's a group called CMD Group. It's a commercial developer who puts together a package on what's happening in our industry on a usually every other month basis. So let me go back to this one here a second and I'll show you. This is what the overall document looks like. It's just a simple 4 or 5 pages, but it gives us a chance to look at what is happening in our industry. So this is the March one. So if you look here, you can see that March's starts rose by almost 32% over the previous month. Okay? Each one of these is indicating commercial, retail, private office, hotel and motel, industrial, institutional, and heavy engineering. Remember in our notes from the chapter 2, we talked about commercial, we talked about residential, we talked about industrial, and we talked about heavy civil as the 4 primary areas. So in commercial, this whole group here, commercial, retail, private office, and hotel and motel, all fall under that commercial brand that we talk about. Industrial, take a look at how much industrial picked up in March. 5,784%. Okay, that's fairly significant. And that's looking as opposed to the amount of work we did in February. And then this one, the green one, looks at how does it compare to the year previous period. So we were 100%, 106% more than we were the year previous, but 5,784% more than what we did in February. So, and then institutional, school, so institutional would be, think of it, hospitals, hospitals and clinics is separated out, schools and colleges, prisons, other facilities like that are all in the institutional category. And then heavy engineering, you can see it's just chugging along at pretty much the same speed it has been. So heavy engineering is where we're dealing with a lot of the public works type projects. And I don't know if you've noticed in budgets and things like now, a lot of government entities don't have a long-term budget. In fact, Congress just approved a 5-month extension of a bill that they extended a while back. Greetings. Would you do me a favor, put an L in front of your name too? And so there hasn't been any impetus to put a lot of money out into the big projects because nobody can look beyond the next 5 months as to what the government's doing. So this was March. Let me flip over to May here. Okay, so May as opposed to April. So this is looking 2 months later. Industrial is continuing to go up heavy. It's still up another 1,900%, 19 times what it was the previous month. So that's moving along well. Then we have commercial, retail, private office, and hotel and motel both took significant drops, both compared to the previous month and compared to the period a year before. So Why do I bring these up? When we talk about the industry, it's always good to know what's going on in our industry. Whether you're going to be designing, because these are starts. So that means that if I'm a designer or an architect, that means that 6 to 9 months prior to this, I should have gotten a commission. In other words, my workload is going up. If this work is going up, it means that the work we've done in our office is now ready to be built. If we're in the construction side, this is the stuff that you've been watching in the Architectural Billings Index that's put out by the AIA. Those are kind of the key indicators that show you what's happening in our industry. They also show you what sector to be in. Now, one of the reasons my first 22 years in architecture and construction, we were pretty successful is we always monitored this. If everybody was building housing, we built warehouses. If everybody was building warehouses, we built stores. If everybody's building stores, we built houses. So we kind of ran counter-cyclical to what the herd was doing, because one of the things that happens, because everybody works off the same set of data, they cannot bet in the same areas. So all of a sudden we get oversaturated in housing, but we don't have enough schools or shopping for those people. We get oversaturated in shopping, but we don't have enough distribution centers, warehouses, and infrastructure to bring things to those stores. So watching the interplay of the industry is really kind of an important, I want to use the word intelligence, like when you're seeking out information as opposed to your knowledge. But it's a really important collection of the intelligence that you need to make good business decisions. So when I see something that pops up in the week, I'll probably put it up on the screen so we can at least look at it. And I'll give you links so you know where to find it yourself. Now, because I am not tied into the internet, as we're going to go along, I will explain what I intended to show you, but we will see how we look at those as we go along. I wanted to talk about what are the construction documents that we use. Architects think of construction documents as two things: the drawings and the specifications and information. Those pretty much are the construction documents that the architect is responsible for creating, because they take that scope of the project and the program that the owner had and communicate them in detail to the people who have to build them. If you stay on and taking my CM minor, the next class that you take is the one called Construction Documents. And it's a CM class. And we don't talk about the first two. We talk about the other 90% of the documents that have to be done in order for a project to be built. Okay? So this is going to be interesting. So that project manual, when I click on that link, brings up a 1,400-page book of specifications, a PDF file that shows, you know, in that project manual, it's got the contract between the owner and the architect. It has the contract form between the owner and the builder. It has the insurance requirements, the bid bond requirements. It has all of these things that if I'm going to be a bidder, I need to know so that I can put together a complete bid package. So that project manual also includes the specifications. Who knows what the specifications say? It gives you the manufacturer of the product or alternate manufacturers that you can use if they're approved. It gives you the specific details about it, and it gives you the quality standards that you must meet. Okay? So when you talk about concrete, it can be 30 pages detailing what kind of sand you can use and what kind of aggregate needs to be there and what kind of cement that you're going to use in the mix and how much air entrainment you're allowed. All these different things that if you tried to put them on the drawings would just be illegible, because this is the detailed information that the people who are purchasing the work need to know so that they can set up their specification, their inspections and quality control systems. So let's take that door because believe it or not, it actually falls in 3 different sections of the specifications. It would fall under doors and windows. It would fall under hollow metal because of the frame. And it would fall under hardware. Okay, so all 3 of those sections. So if I'm going to install that door, furnish and install that door, I know I have to read all of those sections because somebody spent the time to write the information. They made the decision that we wanted to have a door that is, well, is it wood? Is it fiberglass? Is it hollow metal? Is it solid core? Is it hollow core? Is it 18 gauge? Is it 16 gauge? Is it fire rated? All of those things, when you say, well, I need a door, somebody's got to make all those decisions. So the project manual is where those decisions are memorialized for somebody to look at. They want to know, do I have hinges that have 3 screws per leaf, or do I have 4 screws per leaf? Are they 8 gauge or are they 10 gauge? Or maybe if it's a heavy duty door, it could be 12 gauge screws that are there. Are the thickness of the hinges 18 gauge, 22 gauge, 16 gauge, or in many cases 12 gauge, where they're, when you go into an institutional thing. So all of these decisions come into play and need to be included. And when I'm thinking as a designer, most often I put a door there. And it's got a thingy, and it's got an arc, and it fits in the wall, and I'm on to the next thing. Okay, I might say, oh, well, I want it to be 3'0" wide, and I want it to be 6'8" high. But do I think about, well, how does the jamb fit on the wall? Does the wall butt into the jamb? Does the jamb fit over the wall? If it fits over the wall, then what's the exact thickness of the wall so I can specify the hollow metal frame in the right profile to do it? If it varies, do I center the door in the frame, or does the door fit on one side of the frame or on the other side of the frame? What is the hand of the door? Is it a left-hand door? Is it a right-hand door? And you notice how I did that? You put your butt against the butts. That's what the hinges are called. And this is a left-hand door. And this is a right-hand door. So depending on how the door fits in the opening, this happens to be a left-hand reverse bevel door. And it pulls in. So that means that whoever makes the door needs to know that the bevel on the edge of the door has to be on the side that pulls into the room, as opposed to pushing it out of the room. So all of those pieces, I was going to show you that stuff, but I'm telling you about it. Don't forget to sign in. All of those pieces are crucial, and when you think about the entire project, there's got to be specifications for every piece of material that goes into the job. Who writes those things? Architects don't love that job, but that is the architect's responsibility. Now, I remember telling you that I'm really old. Okay, so when we started, the company that I started doing architectural work for, we didn't have a Xerox machine yet. They hadn't made those. Okay, we didn't have a fax machine. We didn't have a printer hooked to a computer because we didn't have computers yet. But we had a typewriter, and if we wanted to do the specifications, you literally took a piece of vellum, like you would draw a drawing on, put a piece of carbon paper on the backside facing it, roll those two into the thing, and then type so that the front and back side of the paper had ink on it, so that when you ran it through the blueprint machine, it would be dark enough for that to transfer. And then the actual books that we gave, the project manual, was a set of 8.5 by 11 blueprints that were put together. So if you made a mistake when you were typing, you had to take it out of the paper, take the carbon off, erase the back side, erase the front side, put it all back together again, and type it one more time. So today when we do, so we were less wordy back then, okay? And I think that there's a lot of stuff that we now put into our project manuals that could just as easily be hyperlinks to information that is now on the web. If I want to specify a collinear, hollow metal, wrap frame, I should be able to click on the specs that are in their website and say that that's the stuff. And then I can say, well, but this is the color I want and this is the size I want. But the technical specs shouldn't have to reside in the project manual. But that's why they're now 1,400, or on the library, 1,900 pages thick, because all of that stuff is in there. What is it? Well, what is their responsibility? If I'm the owner and I know nothing about my building other than I've told you I really want to build this nice office building and I want to have a B-level quality, okay? Not an A-rated building, but a B-level building. So I'm not going to spend the most, I'm not going to get gold-plated hinges. I'm not going to put ball bearing style hinges in, except on the very high usage doors. Where if I was doing an A-rated building, I would probably ask you to specify ball bearing hinges for every door so that they move comfortably. Are they bowling up there again? Yeah. So the architect has to be able to specify, be knowledgeable enough to specify the quality levels. Now, because architects don't like to do it, there are a group of people who are specification writers. And quite often, we used to hire a firm that would do the specifications book for us, because they knew all these sections. They knew where to pull all this stuff from in order to do it. So we would have a couple brainstorming sessions about the generic stuff. They would write it, and then we would have the responsibility to read it because it was going out under our hand and guidance, okay? So while we still had somebody else write it, we had the responsibility for it. It will most often be done during the construction documents phase of the project. So the specifications kind of work the same as the working drawing do. You have a set of conceptual drawings with a conceptual specification, which might just talk about some of the finishes and some of the quality issues. Then you go to the design development, you'll have a more developed specification. And then you get into your construction documents, your working drawings, you'll develop the full. So it needs to be developed parallel with the working drawings. In the projects, a lot of the projects I did, we were the owner, we were the architect, we were the constructor, and we were the end user of the building. And so we did very minimal specifications, and we included more notes on the drawings. But the most important factor was I was there. So when people were doing it, we made sure that when the buying process, we talked about all those things and made sure that the crucial elements we included. We didn't copy other people's work and paste it into our specifications just to make sure that nobody did it. But where I got my real education on specifications was the company that I started working for in 1968 as a draftsman, and then ultimately worked as a laborer out in the field, and then back in the office in Drew, and then they put me out in the project as a project superintendent, and I did all of these things. When the summer we were drawing on a project, in the winter I was sent to that project to clean up, and 2 days before I arrived at the project, they had a collapse. It was a 17-story high-rise. They were doing a floor that was 90 feet by 270 feet long, so they were doing half of the floor. And what they were trying to do was what we call a 3-day pour schedule. So that meant that if I poured this deck 3 days from now, I'd pour the deck on top of it, okay? The problem is with the 3-day pour, all the math says you have to have 3 sets of forms, because you have to support the concrete. Concrete, once I pour it, well, you know, it's liquid when I pour it, and it doesn't turn into rigid concrete for 28 days. You know, it needs to have support. So they were trying to do it with 2 sets of forms and quicker laborers. And what happened is the labor foreman was sick one day, and another labor foreman came in from the hall to run it, and he went underneath the, so if we poured 12, 11 was, the forms were sitting on 11, the 11 forms were sitting on 10, and then the shores were on 9 to 10. What he did is he went in and sent his crew to turn the turnbuckles and drop the panels through all of the floor 11 so they could pull those forms out, lift them up, and put them on top. Well, the methodology that had been agreed on was they would only drop one panel of forms, slide them out, and get the laborers in there and put the other shoring that goes in. It's just jacks and posts that hold it up. And they would do that a panel at a time. The foreman who was there that day didn't know it, and he went through and dropped all of the half of the 270 feet, 135 feet of forms. And the 11th floor and the 12th floor dropped 18 inches. And we were very lucky because concrete, when it starts to move, tends to keep moving. And typically, once a drop like that occurs, it just would pancake all the way down. And they were lucky it just dropped. So I tell you this story because it ties to the specifications. Is 4 years later, I was now graduated from college, working in that office full time. My boss comes in and says, "Hey, George, I want you to meet me downtown tomorrow." I said, "What's going downtown?" He says, "We've got the jury trial on the construction failure, and I want you to have that experience and see why we really pay so much attention to what we do." And I got down there, and my boss was put on the stand, and the attorney for the insurance company beat the crap out of him with the specifications. He said, "Oh, okay, so here it says that you have to do this. What does that mean?" And he says, "Well, it means this." He said, "Well, that's not what it says." And they did that, he must have done that 75 times over a course of 3 hours of finding things in the specifications that said something that wasn't what they meant to say, because they kept reusing pages of the specs as opposed to retyping them. So the specification is a tool that is more often used by the bidders and the attorneys than it is by the architects or the constructors. Okay? It's a really important lesson that I learned that day, and I made sure that in the future, if I was writing a specification, it was about the stuff we were doing, not about everything about specifications. It very specifically dealt with it, and if it could refer to a national standard, it referred to it as opposed to included it. And that's what we learned. So those two things are really in the architect's world. When we do a design build, it's in the world of the design build entity. Both sides have to be working on that, because I might say, you know, I really like those brass colored ones, and my estimator can say, well, that's fine. It's just that they cost like $3 each more. So for every door opening you drew, it's $10. And if there's 1,000 drawer openings on the building, it's $10,000. Now, how much do you like those brass ones? You know, and those kind of decisions can be made in a design build thing, where the architect might say, I want the brass one, so he draws them all in brass. Everybody bids it, the price comes in high, and it isn't until they go back through value engineering and waste time that they find that there's a place that the owner didn't care whether they were brass or chrome, you know. So it was the architect's selection. And because of that selection that's not informed by cost, it was informed by visual, then it can affect the overall cost of the project. So it's one of the great reasons why designing in a design build situation really helps an architect to become more familiar with the values of the decisions that they're making. Yes, if you're going to have public money, you're absolutely going to have a project manual, because the bonding information, everything else that's got to be in there, you know, where do you dispose of dirt? How do you handle stormwater? All of those things have to be defined either in the working drawings or in the project manual. And in the project manual, you're probably going to have all the forms that somebody's going to have to report their quality work on, so that there's a method to it. And then there's somebody in the architect's office who's going to have to be receiving this stuff on a continuous basis, documenting it, filing it, putting it away, and making sure that their records show that everybody was up to speed on it. The third thing that happens is when we get the project bid. How many of you have worked on a set of construction documents, actually working drawings? Okay. So I spend a lot of time on working drawings. And I think, man, I really got it down pat. Truth of the matter is, my working drawings are very little use to the actual tradespeople in the field. Because I might put dimensions on my plans for the walls, the space between the bathrooms, the thickness of the chase, all that stuff. Well, the guy who's got to go out there and put the pipe in that chase before the floor is poured, none of my dimensions add up to anything because they don't exist. I dimension to things that will be there when the project is done in the future. So they end up doing what are called shop drawings, which they'll take, and maybe for the plumber, his shop drawing is nothing but the shape of the floor with a bunch of holes and dimensions of those holes to physical elements that will be in place at the time the guy goes out there. Okay? So somebody has to do those drawings. They do shop drawings so that the plumber knows where to put the blockouts for his plumbing. They do shop drawings to show where the light fixture boxes will be embedded in the concrete so that it can be there, and where the conduit runs so it doesn't conflict with the reinforcing that's in that concrete. There's people who do shop drawings for where does the reinforcing go, so that not only where does it go in the erection plan, but exactly how is it fabricated in the shop before it gets shipped out there. So all of these things are going on continuously, and all of them require an architect's review. So in the project manual, it'll say, Raymond, you're the reinforcing steel contractor. I need from you 6 complete set of shop fabrication details, 6 complete erection plans, and a list of how many pounds of material you're going to deliver in each lift so that we can work our lifting capacities. So you're going to have to hire somebody to do a set of drawings that shows where all of the stuff is, so that your labor that you hire to put the stuff in the field knows exactly where it goes. And then the guys who are in the shop who are taking those rebars and putting the bends and hooks in them and labeling them so that everybody knows that that's a 1R73 bend, and there's 10 of them I need for the floor, and they go here, here, and here. All of that stuff has to be put into the shop drawings. You send it to me as the CM. I keep 1 copy. I take the other 5 copies and stamp them with the stamps that we're going to want filled out by certain people, and I ship them all to the architect. So I've got 1 copy in my office. The architect has the other 5 copies. Now the architect may go through all 5 of those copies and check them for what I have to now do is called review for compliance, that the dimensions you used are in fact the dimensions of the set of drawings, that the openings that you've assumed are actually where I want those openings. And I'll take a set of those or 2 sets of those and send them to the structural engineer so he can look at the actual placements of the bars and the bending of the bars. Then he'll take one and sign it that he's reviewed it for compliance and it's okay to fabricate. He'll send 1 set back to me or 2 sets back to me. I'll do mine, and then I'll send 3 sets back to the CM, and then those will get distributed for people's record sets. So one will go to the job site that shows that they've got approved shop drawings that they're working from. One will go into the job file in the office. One will go back to the fabricator. One will go back to the installer. And those become the real documents that we build the building from. So today, yeah, Raymond. Okay, the working drawings are the actual drawings that the architect and designer produce. They show materials, they show room arrangements, they show finishes, they show reflected ceiling plates, they show They showed the aggregated information of the whole project, okay, with details of how you want it to go together. The shop drawings are every specific set of details that pertain to my material. Like, there's going to be a book this thick that has the shop drawing information for every door. What frame is it? Okay. What hardware set goes with it? Because I don't just back up and dump a truckload of hinges out. I send it to the job site boxed and identified for every door opening. So if I have this door called an A1 door and it appears on 20 floors, I'm going to have a box of hardware for it 20 times. Each one identified to a specific floor and a specific location, so we can control the inventory for that. And it's going to include the hinges, it'll include the lock set, it'll include a closer if it's got it, it'll include a sweep if it's got it, it'll include all of that stuff that we don't think about when we just show that line and arc on the drawing. So the shop drawings tell the trades how to do their job. Now, their knowledge of how to do the materials is what gives you productivity. Well, here's the most interesting thing. Mostly high school draftsmen. Uneducated, cheap drafting services. Believe it or not. I mean, my first job in high school was I did shop drawings for open web steel bar joists and metal deck. I had no engineering training. I had no anything. I just worked from the architect and engineer's drawings, and I did an erection plan that looks similar to it. I couldn't put my information on their drawing because it was their drawing. So we sometimes would do an overlay of a drawing and trace the outside of the building and put their dimensions on. But then we literally had to say, this bar joist is 42 feet, 3 3/4 inches long, and it's got this kind of end on it. I was 17 years old, right out of high school, and I was doing that. And then the drawings that we were doing were being sent to the architect, and they would review them for compliance. The engineer would review our calculations on the bent pipes that go in there that are, and how the weldings were done. And then it would go down to a steel fabricating company in this little town where everybody you didn't like in high school was working in the shop, because they, so you were talking about low-end labor who was building these structural elements that were going to go, low-end labor that was building structural elements off plans prepared by somebody with no education or no understanding to build and hold up the roof on a building. That's how shop drawings get. That's why when I used to say approved, I was on the hook for it. That's why it now says reviewed for compliance. So if your work is failing, your insurance is going to cover it. Now, if I haven't checked the dimensions properly, that's going to fall back to me. But still, I'm not approving your work. I'm reviewing it to make sure that it complies with the requirements of the drawings. So it's really an interesting thing. And now with the electronic models, we had high school draftsmen who really understood AutoCAD and Revit and stuff like that, who became the ones who were doing the models for the mechanical, electrical, and plumbing people, the people who have ingrained the project of using electronic models. They're the ones who really understand how it works. And I took a class once out to University Mechanical, and they've got this fantastic big room with like 40 stations set up where they can, and projectors, and they can sit down in that room with every engineer, architect, constructor, and detailer on the project and work together on the model to solve all their solutions. But everybody who's a detailer there is someone who came from the trades. They took the people who were most knowledgeable about how to use the material and trained them how to use the computer. And so that's where most of the people who are then doing the electronic model to generate the shop drawings for the mechanical, electrical, and plumbing trades are. And one of the reasons that is that if you get really good at Revit and you draw a model that is just totally works, under the way that the laws are set up and the contracts are set up, your company owns that model and nobody else can use it. So they can extract something from that model and modify it and change it. But as soon as they do that, it becomes their liability. So that's one of the biggest problems with the integrated project delivery system we talked about, is that unless we get like the gamers, where 600 people all over the world are playing in the same database and watching the activity, if we could get that way in our models, we would knock out 90% of the waste that we have in the process. Because if you were the best modeler and you drew it, and I was able to be in there, and Raymond is the estimator on the project, and somebody goes in and makes a change in your model and it dings on his desktop that somebody changed it, he knows now that you changed the door widths from 3 foot to 4 foot because you decided you wanted wider doors. Well, all of a sudden, he'll be on the phone to you and say, hey, that little change quintuples the cost of each of those doors. If we went to 3'4", you'd have a bigger feeling door, but it would fall in the same cost range as a 3-foot door. You go to a 4-foot door, all the physics are different. The hardware's heavier, the doors are heavier, the frames have to be reinforced more, the hardware has to be a 5-screw hardware as opposed to a 4-screw hardware. So if you made a change in a design and he could see it immediately, that would be great. But today you'll wrap up at the end of the day, you save your model, and you might put it up on a server where everybody else then can draw that down tomorrow. But all the work that they did yesterday is on a different model. It's on the model that you worked on 2 days ago. So what happens is we end up building the building from the most immediately obsolete information. Okay? By the time the shop drawings are done, by somebody who doesn't totally understand the concept, by the time they go through the approval process and get out there, because we can make changes easily in an electronic model, we end up making changes that never get through the process and out to the field. And it causes a great deal of challenge in putting the building together. I ask my students who graduate in CM, when they come back after a year or two, I said, what could I have taught you better? Most recently, the guy who came in and said, I wish I knew more about MPE. Okay? And I don't teach MPE because they take it in a class with the architects. Okay? And it turns out that in the architecture class, they don't teach much MPE either. I think University of Mechanical's concept is absolutely on target. The people who need to model that stuff have to know that material. I know how to drive a car, but I may not know how to design the springs on a car. So we're better to have a mechanical engineer design the springs on the car while I drive it. So there are specialties and there are reasons for it. My feeling is you should be able to be conversant in the systems so that you can talk to the people who are designing it. And you can talk to your client because he's paying you to be able to specify that stuff. But you really need the phone number for your mechanical engineer more than anything else. So the way we teach architecture is the way that we've taught architecture for the last 50, 60 plus years. Get the design, get the social issues, get all of the things regarding the interface with the human experience. And then when you go out of here, you are now graduated from that to the place where you do your intern development program. And it's really, you learn those other details depending on which of those categories of construction you go into. Whether you go into, if you're going into industrial, you need very little information on bathroom design. Okay, so you're going to learn a lot about the industrial design and pipes and brackets and framing and earthquake resistance and all of the stuff that has to be there by working in that firm. So the architectural community has said, we don't have enough time in 5 years to teach you everything you need to know about being a responsible licensed architect. We can teach you all of the academic side of things, but the instructional side of things you need to learn in that IDP. Now, this new concept of license upon graduation, the LUG program, is the concept of stretching the program out by another year, but putting you out in the field for 1/4 of each of those years. So literally getting some dirt on your boots and understanding what it is in the field. Meeting the people who are, it used to be that way in the English system, is you literally served, I think it was 4 6-month internships in the trades before you were qualified to sit for your exam. So we need to learn those things. I think the more you know about systems, the more valuable you are to the firm that's there. Because remember, all of the people who own the firm were taught pretty much the same way you were, okay? So if you know more about systems, if you know more about construction administration, they're probably going to love you because you'll be able to do something that they have never really been trained in or don't really want to do. So I think our models are going to become the elements by which we do it. I think we should be able to build that building in virtual space, remove all the conflicts, and then generate a model out to the field that is capable of being built without conflict. I think we could do that. We're not there yet because we still hold on to our old, well, those are my drawings. And no, you had your kid draw that shop drawing, and we're going to let you have the responsibilities, as opposed to, I can do a layer in the model that's the shop drawings. I can push a couple buttons and produce a plan that just shows the holes with center dimensions of all the holes, so that that shop drawing for the plumber flows right out of the model. And the latest model, because whatever Raymond did on the model yesterday is in that model. That's where we got to go. But until we can work in the same space simultaneously, I think it's going to mean we need to change the method by which we store the elements within the models. Then we're going to be able to do some of those things. But as computer speeds go up and as communication speeds go up, I see that becoming, certainly within your lifetime, okay? Because you're going to now build a model, push a button, and they'll 3D print a 72-story building without a problem. Okay, so this is in the project manual that I was going to show you. Each of these links takes you to a different section of that project manual. The contract between the owner and architect, why does that need to be in the model? Well, it's because it defines the scope of the project and the scope of the work that the architect was engaged to do. If I'm bidding the project expecting the architect to prepare shop drawings, and it's not within his scope of work, there's going to be a gap in the bid. So I need to know what the architect has, his responsibilities to the owner are. I have to see the contract between the owner and the construction manager. What's the owner going to pay George for? And what is his responsibility? Where does he fall in the communications path? How do we move things through so it's efficient? Then you also end up with general conditions of the project. General conditions of the project is a standard form nowadays. And it literally goes through and basically says, this is how the industry has decided we build. So you don't need to bring power to the job site for your carpenters today. It's the general contractor's responsibility to have power available for you. But it's not the general contractor's responsibility to bring power cords to get that power to where you're working. That's your responsibility. It's the owner's responsibility to pay for the utility charges for that power that comes to the job site. Okay? So that I don't say, well, I'm going to put $1 million in for power. Okay? In the conditions of the contract, it defines how the general conditions. Who's going to pay for office space? Who's going to have the right to use it? Where are documents filed? All of that kind of information is in there. It's about a 25-page document. It's called AIA 201, and it is been in existence pretty much since 1973 with, I think, 3 updates, and it pretty much is a consistent document. So we almost always say in our drawings that the general conditions of the project, AIA document 201, are included as if bound herein. Okay? That way everybody knows that's the basic thing. Now you get into a thing called supplemental general conditions, which may be things that are very specific to this site. So on this site, we might have a dewatering part. Well, dewatering is going to You know, that's where they drive pipes down in the ground and they suck the water out of the ground so that they can lower the water table and make the site dry. Well, while we're doing that, it affects everybody, because if you back into the dewatering system, the pool, the foundation will fill up with water, and you can't have that happen. So but that's not a general condition of the site. That's a supplemental general condition. So it'll define who's responsible for that, who has to monitor that stuff, etc. What are the qualification requirements for the contractor? That's another document that AIA puts out that's in there. Then we put the form for the contract between the owner and the contractor. Because we haven't met you yet, you haven't got the contract because you're bidding it now, you need to know under what terms am I bidding this contract. Okay? I had one special thing in my contract for the project I did in Wisconsin that said that I was responsible for securing the builder's risk insurance for each building on behalf of the owner. And because it was in my contract, then I was able to do it on a continuous basis, where if it wasn't in my contract, he needed to have 245 separate policies, one for each address. Okay? But because it was in my contract, I was able to buy a bulk package that was able to do it and charge him for that thing. So that's, if I didn't know that up front, I wouldn't have included it in my prices, and we would have had a problem. Then you get into the working drawings. And the working drawings, I have a video that shows me pointing like this at the screen at a set of working drawings drawn in 1924 for the Moody Church in downtown Chicago. It was a 4,200 seat, balconied, cantilevered, column-free auditorium that was built in 1924 for a little over $500,000. And there were 16 sheets of drawings to build this building. They did an addition to that building in 2000, and by the way, my grandfather was on the building committee on that. So I actually had, for a period of time in my life, the original linen drawings with the original India ink of the actual documents that were done. When they did the addition in 2004, there are 800 sheets of drawings to put up a 3-story classroom building with bathrooms and an elevator. And it cost a little bit over $8 million. Okay? And is it because the old people just didn't do a good job of communicating the information? No, it's because the litigation has gotten so crazy, and the tools that we have, I can now take that same section and put it here and put it here and put it here and put it here and repeat it all over the place. Of course, it doesn't update every time I make a change to it, you know. Right. You know that somebody's going to sue you, you just don't know where it's coming from yet. You know, and so the question becomes, do you try to do everything you possibly can to prevent being sued? Or do you do everything that you need to do in order to build the building and then take the risk that if that isn't adequate? But I have to say that 800 sheet set of drawings and going, I've never looked at every page. I mean, I looked at several of them and I said, you know, okay, I know enough of I can go build that. Because the details were meaningless. You know, it's so repetitive, it becomes really meaningless. So we'll look at some of those details when we go walk one of the job sites that's finished, because I want you to see where it becomes really important to do your detailing. Or there's a note that we used to jokingly put on drawings. When we couldn't figure out how the two materials came together, it was beat the shit out of it. No, beat the hell out of it and caulk the shit out of it. That was the solution to solving the problem. And so you don't really want to do that. You want to have a design for each place where materials change direction and do stuff. So in the set of working drawings today, you'll end up with a cover sheet that gives you all of the listing of the drawings and who to sue. Okay, everybody's name's on the front sheet. Then you get into the actual details of what those drawings are. The civil drawings will cover all of the work that needs to be done to the site to prepare it for construction and to finish it after construction to have the shape and configuration that you want. The architectural drawings will include everything that is the shape and form and materials of the building. The structural drawings will be the drawings that show both the means and methods by which the weight will be transferred from its forces into the ground. The mechanical drawings will show all of the things that are there to provide ventilation, like we don't have in here, or heating or cooling. Electrical drawings, how do we get power through the building? And the specialty drawings, like in this particular one, I had a banquet kitchen and a banquet hall that seats 600 people. So that banquet kitchen in the specialty drawings, there's almost as many drawings in the specialty drawings for the kitchens as there were structural drawings for the building, because of every piece of equipment that has to get put in has very specific connection points, and so it can only have whips that go so far or flexible things that goes. So you literally have to know exactly to the quarter of an inch where pipes have to come out of the floor, where pipes have to come out of the wall in order to install this stuff. So, and then I have a set of photos to show you what it looks like when it's done. So, and I actually have a video that's online that you can look at where it shows you, takes you inside and outside the whole project. Because this project was a 75,000 square foot indoor water park with a 100-room hotel, a 600 seat banquet facility, 275 seat restaurant in the hotel lobby, and then 245 log cabins around it that provided housing for people to come and stay. So it's a pretty complex little project. I built that from 2003 to 2008, about $245 million worth of construction. So let's take a break at that point, okay? So while we're waiting for everybody else to get back in. So this, found a couple of the photographs. This is the water park, the indoor water park. This was a little skate park I built back in 2003, before they really started building a lot of skate parks. This is the hotel, the lodges that they have. You'll like this picture. See this picture? You'll get to know this building before this quarter's out. So there's the patio off the dining room or the restroom. Has some nice features. Now, interesting. So this is the inside of the water park. When you're, and this is standing on the tower where the water slides are, because the water slides go in and out of the building. This volume of space is kept at 82 degrees, 70% humidity year round. When it's 110 degrees outside, and when it's 25 below zero. So the mechanical system, you can see, look at this. This is a 6-foot diameter duct that brings in air from, and because of its being an indoor water park, you have to bring almost 100% outside air in. You can't recirculate the air because the little flakes of skin that come off over time, if you recirculate it, it lays up on edges, and that's where mold starts. Okay? So you 100% bring in fresh air all the time. And then if it's 25 below zero, you got to heat it from 25 below zero to 85 degrees or better to bring and blow it in.
What system did you guys use?
It's warm air, gas-fired, propane-fired actually, system. Huge burners. Now we use boilers for high-efficiency boilers to heat the pools. And we use the pool water as a heat sink for the air conditioning and heating for the hotel, for the lobby area, because we could take the air conditioning that's running in there and take the heat out of that and put it in the water and not have to heat it. And if it was really cold, then we could heat the water up a little more, draw the heat out of the water, and put it into the air. So it was really an integrated system. It's a custom, yeah, it's designed we had a mechanical engineer who was a former NASA engineer who worked on the project for about 6 months, produced a set of drawings that was 3 times the budget for the mechanical equipment. And then we ended up hiring a mechanical installation firm to design and build the system, because he had redundancies in there that, you know, we weren't going to the moon. You know, I advocated that we hire a Navy Master Chief who had the experience of running a battleship, because the mechanical system in that building, the pump room is like 3 times the size of this room, just with continuous pumps that circulate that water through the water slides, through the pools, through everywhere. It's really quite amazing. So I think this element here, which was designed by NBGS out of San Antonio, this system alone has 20 pumps. And it fills up, there's a bucket up there at the top. It fills that bucket with water every 8 minutes. And then when it gets to a certain level, it becomes unbalanced, tilts over, and dumps it all off on the kids down below. So it's running, it's amazing, both the engineering support that you need to have to keep one of these places running and the cost of utilities that it takes to keep them running. So that's what the inside of the place looks like. I'm down at this one. I am going to skip these 2 slides and we'll pick those up next week, because I need to get back into this. How do we get work? Remember what we talked about on Tuesday. We talked about you needed to be on the list, you needed to know your qualifications, you needed to do all these other things. So let's go through those a little bit. Be on the list. Remember what an RFP is? Well, speaking of that, would you pass these around?